Hi everyone, welcome to today's webinar on X-Rite inline solutions for plastics. Presenting today we have Freddie Binder, the Sales and Marketing Director for our Munich inline solutions. I'm Amanda Carter, one of X-Rite's North American Marketing Managers, and I will be moderating today's webinar. A few things before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. During the webinar, if you have questions, please use the questions function on the GoToWebinar panel. We'll have time at the end to answer a few questions, and if we don't get to yours, we'll have someone to follow up with you. And finally, this webinar will be recorded, and you'll receive a link so you can review the webinar at your convenience. I'll now turn it over to Freddie.
So hello everybody. Let me start this session with two questions at the beginning. First question, we are here to talk about color. Why do we have to talk about color? Why is color so important? Well, I think the most interesting thing is color is a primary quality criteria. Look at the lady. She has a bottle in her hand and she looks at the shelf having different bottles, different colors. She doesn't have to be a specialist. She sees that there is something wrong. Guess which bottle would she pick? Most likely she will pick the bottle from the upper shelf because they are all similar. So we do not need to be specialists. We do not need to have an instrument to measure something. We can see color. Everybody can see it. A child, adult, men, women, whatever. Everybody can see it. And this is why I say color is so important. Or look at this kitchen desk or this kitchen front. There is one panel which looks different. Would you accept this? For sure not. The kitchen is functioning well, but it looks different. We do not like it. It's a primary quality criteria, and we are sensitive to that. So second question, if I say we see it and everybody can have a look at it, why should we measure it? I think this is easy to answer with the next slide. If I show you this color swatch here, I show it to you for some seconds, and if I move it away, and just a few seconds later, I show you a selection of different color swatches. Which one was it? I guess you have 16 chances, and if I make a voting, we will have all 16 colors. Everybody would say something else. You cannot remember the color. You can only see it if you have it side by side. It was the swatch number N. So if you put it really side by side, very close, then you can realize which color it is. And this is the problem why we need to measure the color. We need an instrument which helps us to have a color measured today and in 1 week and maybe in 1 year. So we are talking about the plastics industry. What products can we measure? Nearly all of the product processes start with pellets. So this is the first stage in the production of any kind of plastics. We can measure the pellets at the beginning to see if the color is right. But then this is not the finished product for sure, so we continue and make, for example, a film out of it. If we have solid materials, it could be plain color or structured materials, even some patterns on it, we can measure directly on the production machine. If you look at these products, these multi-wall sheets, it's very difficult even to measure them in the laboratory because you have sometimes these walls in between which give a different viewing or a different looking at the sheet. It's difficult to measure it in the laboratory. We can imagine it's even more difficult to measure it on the machine, but I will show you a solution how this can also be done. And last but not least, of course, we can also measure any kind of transparent or translucent materials. So, why do we go for an inline color measurement? This is some general things. I mean, if you look at the different processes, there are always different kinds, different ways how to make a return on investment, how to prove why it makes sense. This is just a general overview. Typically, we have a much shorter startup time of the machine, or if you go from shade changes from one color to the other color, we can save typically 20 to 50% of the time going from one color to the other color, or even on the startup. then the operator sees what's going on his machine. So if the color is going out of the target or whatever, if it's moving in one direction, he can see it and he can immediately react. So this helps him to have a constant good quality, and it avoids, we say, 25 to 35% of waste. So in total, you can reduce the waste dramatically, 20 to 50%. And it gives you a documentation of the entire process, which helps you to prove against your customers to say, look, this is what we deliver. This is why we have a good color. Okay, this is now very theoretical. I want to give you an overview how a typical process looks like in a plant. So I have here a company, virtual company, which makes any kind of product. On the left-hand side, you see a truck bringing some raw material. Nearly every company has a QC, a quality control laboratory, which is doing an incoming inspection. So they check how the material looks like. Then the material is processed somewhere on the machine. And at the end, when the product is finished, it goes again to the laboratory. They check whether the quality is right. And hopefully, when it's right, it gets a green light and it goes out to your customers. But what happens if it's red? Well, then you can rework it, or you can stop it, or it's maybe even waste. So then it's too late to tell the people from production what's going on. I sometimes call this also a post-mortem examination. So it's too late to do something. The poor guy on the production machine, he is running like blind. He has no idea what he is doing. The laboratory says, just try to go on, and at the end we tell you whether it was good or wrong. This is like driving a Ferrari, and I let you have a look on the road, and then I shade your eyes with a eye blind or whatever, and then you have to go, and hopefully you will stay on the road. If you leave it, well, then you lost it. So this is a poor guy. What you can do is, if you have an inline measurement directly on your production machine, it gives the operator of the machine a continuous feedback. So he can react immediately and see how to adjust his process to stay on color target, or if you look at the Ferrari, to stay on the road. This could be in two ways. We can only show you the measurements and say, where is your color? And then you can manually adjust it to be on target. Or if it's a more advanced system, you can have a closed loop control, which even does these color corrections automatically. So it goes back, it brings the color back to the target. And there is a saying, only what you can control, only what you can measure, you can control on the machine. So if color is important for you, you have to measure it, otherwise you cannot control it. So this is why we need this color measurement. We have now different platforms, I would say, to measure the color. So first of all, we have to divide reflective materials and transmission materials, so transparent things. If you look at these reflectance materials, we have these, the most biggest group is this ERX50 and ERX130 group. These are two measurements which have a very accurate measurement. It's the same like in the laboratory. And there is I would call it a mid-end solution, which is the VeriColor, which has, it's more like a trend measurement, but therefore it's much cheaper. And if you go for transmission measurement, you have this ERX55, which is a transmission instrument. Let me give you some examples. For example, I told you, first thing, what is typically in the plastic process are the pellets. So here we have a pellet measurement, and you have a sorter over here. We measure directly the pellets on the sorter. This is a very nice technology. As we measure with a flashlight, these moving pellets are stable for our picture, what we made for our color measurement. So there is no influence of the speed or of the vibration of these swinging drops. It has a special geometry, which I show you in the next slide, to avoid shadows, to have a very clear measurement. Most of our instruments do have an internal calibration. This is very important because in the production machine, you have different temperatures, you have dust, you have vibrations on the machine. all of these things influence the measurement. In the laboratory, you have to calibrate every, I don't know, 6 hours, 8 hours, once a day, whatever. Inline, you have to do this more often because of these environmental conditions. So this instrument has an internal calibration. It's very stable along many weeks. Then you have to do an external calibration, and it's also very stable for many years because you always bring it back to a target. You can have very often the same instrument for the inline measurement like in the laboratory. That means you have an excellent inter-instrument agreement. And this instrument measures with a diameter of 3.5 inches and a distance of 12 inches. Let me explain you a little bit more about the geometry. So what we have here, we have this coaxial geometry. That means we illuminate a parallel beam to the product, and right in the center, we measure the color. It's like if you have a camera which has a ring flash around your lens. So you have no shadows. You can see this on that slide. So the yellow arrows are the light which are illuminating. And of course, we do have a shadow at the back side of these pellets or whatever it is, but we do not see the shadow because we are looking from the same side. So this makes this measurement very easy, very reliable, independent if these pellets are a little bit bigger or a little bit shorter, if they are oval or perfectly round, whatever, the measurement is very reliable. Normally we talk about systems. So what we do is we do not sell only a piece of measurement head and a piece of software. There is a lot of things in between. Typically the computer is somewhere into the operator's room. That means we have a huge distance from the operator's room to the production machine. We normally have this long distance with a CAN bus. So you see here, this could be up to 1,600 feet. Close to the instrument, we have a power supply. We get some machine signals, for example, a machine stop. If the pellets do not come or are stopped somehow, we stop the measurement as well. Close to the computer, we have a signal converter so that we can use a regular computer with just a USB interface. And here we can also include some host system, I would call it, where you totally can, if you want, totally can control or remote control our system from your host system. I have made here a small return on investment or a cost savings. So if we say this system costs around 97 or let's say 88,000 US dollars, and you have an estimated lifetime which is much longer than 10 years, and this is really very conservative. If you have an extrusion line which makes 500 tons per hour, and you have a product price of $2.6 per kilogram, and make 10 hours per year production loss because of color, which is really not a lot. 10 hours per year, it's really nothing. So you can save $130,000 per year. That means after 8 months, the system is paid off. This is a very conservative calculation. So we have very often people who say the system has paid off in 6 months, even 3 months we hear. So this is quite nice. Now, this is this VeriColor Spectro, which I mentioned. We use this very often for profiles, or especially in America for this vinyl siding. It's a LED-based technology, a bit more simple, a bit more cheaper, but it's a very reliable system for these profiles, things, or for any continuous measurements. It's typically placed with a distance of 2.2 inches, free clearance to the instrument, to the product, and it has a measurement spot of 1 inch. This is a more high-end system. It's a plastic film. This is a company which is producing all these credit cards which we are using. So most likely your credit card is measured with this ERX50 instrument. With this instrument, we can also measure whiteness, brightness, or opacity. So these are the typical values which we measure. We can measure, of course, all the color values like LAB, C and H values, but we measure also whiteness or brightness. We can measure yellowness. Opacity is, especially for films, a very interesting theme. If there is OBA in the film, we measure fluorescence. We can measure optical density, and sometimes the dominant wavelength is also interesting for our customers. With this ERX130, which we used before for this pellets measurement, we can also measure multi-wall sheets. The reason is with the large spot of this instrument, we always have some walls of this multi-wall sheet in our measurement aperture. So that means even if the product is shifting a little bit from left to right, from operator side to drive side, we have very constant measurement because the big spot of 3.5 inches always have some walls inside. If the material is very transparent, we can use a white backing. The white backing gives us some reflection, and it's not a transmission measurement, but it's somehow like a transmission measurement. So this helps to measure transparent stuff. But if the product becomes more and more transparent, we would use another system, which is called the ERX55. So you see here we have a frame which goes around the sheet. We have here a polycarbonate sheet, very transparent. From the bottom, we illuminate, and from the top side, we take the measurement. So this is a principle how it looks like. This instrument is always on a linear track, so that we can move it in the web and can move it out. So what you see here, this is the part position. If we start the measurement, the instrument moves inside. We make our flashes. And as I said, also this instrument needs to be calibrated in a frequent interval. That means typically we set up a calibration every 15 minutes, but we also measure the temperature of the instrument itself. Because if the temperature changes of the instrument, we need to recalibrate it. That means after these 15 minutes, or when the temperature is changing, we move out again, do the calibration in air, and then we can move in again to make the measurements and continue with the measurements. So this is how the system looks like. Again, we have a large distance to the computer, and we can connect external signals. For example, if the web is breaking, we move out automatically. All these things. This is how it looks like in reality. Here we have turned it around on the top side. We have made here a cooling box because this material is quite hot. If it's too hot for the instrument, we make a cooling box around it to cool it down with air typically. And you can see in front of the instrument, there is a so-called whisker sensor. So this is a very thick sheet or a pane even. Sometimes it doesn't come out like this very smoothly. Sometimes it comes out in big waves. As we do not want to destroy our instrument, as soon as the whisker sensor gets hurted, the instrument will move out. The operators can set up their machine and everything will run again. So this is kind of hardware what we have. Next one shows you the software. This is how the software looks like. And you see it's quite easy. We have here 5 diagrams. The top diagram with the black and white bars, it shows the L value. The next diagram shows the A values. The next diagram shows the B values. And then we have in this case, for example, a delta E, and I think it's an opacity value. And it's very easy to read. If you look at the top diagram, it's white and black. So if the bars are too white, it's too light. If they are black, it's too black. Next diagram is the A value. If they are red, it's to red. If they are green, it's to green. And the same with the B value, to yellow and to blue. So you can see immediately at the one glance, the last measurement is a little bit to white, a little bit to green, a little bit to yellow. So you do not have to be a color expert, you see where you are. The whole system, the whole software is operated by the buttons which you can see on the left-hand side. And you see there is a start button which starts the measurement. Then there is a button which is called interrupt to stop it, continue to restart it again. Then you can change times and you can even make a correction to the laboratory. We always say with these inline color measurements, we want to be a help for the operators. We are never competing with the laboratory. if the laboratory has a certain value, we always say the laboratory is right, and we correct our measurements to the laboratory. So this is what we can do. We take the same absolute values of the laboratory and then make a correction. We do have a lot of customers which are happy with our systems. These are just a few names which I'm allowed to mention. I have a written allowance that we can use their names. We can even give them to you, to contacts or whatever. So that was it from my side. Any questions?
It looks like we have a couple questions from the attendees. One of them is a closed loop control possible on transparent films?
Yes, it's possible. We have done recently a trial at a big sports manufacturer, and it works quite fine. So I'm not sure how much I'm allowed to say. So they want to keep a certain color value, and they have at the beginning of the process a feeder with a blue master batch, and we control this feeder to get it always on the same color. We have also another closed loop control application for window films, where we control not only the blue, we control up to 3 dyes to make the window film a certain color. So this works pretty well. Yeah.
Okay, and looks like we have one more here. Is there an influence on ambient light?
Absolutely not. Even if we have this instrument which has a huge distance, there is definitely no influence of ambient light. So if the sun is shining or if the sun is out, you can even take a flash lamp, flash or light on the spot where we measure or into the instrument. The trick is very easy. Before we make a flash, we measure the ambient light, and then we do the flash, and then we have 2 measurements, flash off and flash on. So the difference between these 2 measurements is now only the flash without the ambient light. So all the measurements are done in a very precise way, no influence of ambient light.
All right, thank you, Freddie. That was the last question that we have time for. So that marks the end of our webinar. Thanks everyone for joining. If we weren't able to get to your question, we'll follow up. You'll receive an email with a link to the recording of this webinar. Thanks again for joining, and everyone have a great day.
Thank you very much, everybody. Bye-bye.